Hey everyone, so I think we're live now. I just wanted to quickly record a demo of the clustering feature we've landed in LXD 3.0. LXD 3 has been released a few days ago and started rolling out to users over the past 24 hours or so. And LXD clustering is by far the most exciting feature we've got in this release. And I just wanted to show you how easy it is to use with a number of systems I've got around here. Should just take 10-15 minutes, and pretty cool and pretty easy to do if you've got some spare hardware around the house. So to do this demo, I've got a number of systems here that are in MAAS. MAAS, for those who don't know, is Metal as a Service. It is a server that lets you effectively pixie boot and auto-install and configure your servers, as well as pre-configure a number of things like storage and network on those machines. So for this demo, I've got three systems called Janet, Edfu, and Nutero here. They're all pretty similarly spec'd old Intel Xeon servers with a reasonable amount of RAM, some disks, and some, well, they've got identical network. So on the network side, I can just go see on that system. What I've got is IPv4 and IPv6 networking. It's configured as it's going to be made available to the physical system as a bridge in the operating system. I've installed all three of those nodes with Ubuntu 16.04. They're freshly installed. I've not connected to any of them yet. So it's a completely blank Ubuntu server install with whatever comes with it in Ubuntu 16.04. Now, if I switch over to a terminal, there we go. So let's just connect to all three systems. So I'm doing Janet first, then Edfu, and then Nutero. There we go. Can I use the first one as our first cluster node? But first, because Ubuntu 16.04 came with LXD 2.0 pre-installed, we don't want any of that stuff laying around. And since it's not configured or anything, I'm just going to remove all those components. And I'm going to be running that exact same command on all three of them. So it just removes any remnant of the pre-installed LXD 2.0 that those systems have. With that being done, I can now just install the LXD snap, which right now is LXD 3.0.0. I'm going to do that on all three systems. There we go. Just need to wait for that to complete. LXD 3.0 will be shipping by default in Ubuntu 18.04 as a deb there, but users of other distributions or older Ubuntu releases can install it through the snap, which we test and fully support. Just checking that all systems are making good progress on that. Looks like they are. It doesn't really matter what systems you use to set up LXD clustering. The actual CPU and memory can differ between machines. They should be of the same architecture, but what matters the most is that storage network is identical. Otherwise, you can't really have a consistent cluster at the end. Yeah, so it looks like the first one is installed, the second one is getting there, and the last one is still downloading and configuring right now. Okay, so we can configure the first one. I'm just going to share the screen. So to configure LXD, as you always would, you run LXD init. Now, there's an extra question, one new question that's added. It's actually the first one, and it asks you whether you want to use LXD clustering. I'm going to answer yes to that. It picks the default host name as the machine's name, which is perfectly fine. Picks the IP address of that system. I can check on one of the other ones. There should be, as configured by MAAS, yeah, there's a bridge called BR0 that's configured with both IPv4 and IPv6, exactly as was configured in MAAS. All machines are going to have a similar configuration. So IP address is fine. We're not joining an existing cluster because we're creating a new one. We want to be able to connect that cluster authenticating simply by password initially. That's much easier. So let's just do that. Let's use my cluster as the password, I guess. Easy enough. Yes, we do want to set up storage. ZFS seems like a good idea. Yes, we'll create a new pool. We're not going to use a physical disk. We'll just use a loop for this demo. That's perfectly fine. We will not add a remote storage pool at this time because those systems are not connected to Ceph or any type of shared storage. Since I'm using MAAS, I will say that I want to connect to a MAAS server. It asks me what's the name of this specific machine in MAAS. In this case, it happens to match its host name. Then the URL of the MAAS server, which is dot, and then a valid API key. I've generated a new one for this demo, so it's going to paste that in there. There we go. Then I don't actually want to create a new bridge because we've got one from MAAS. So yes, I would like to use an existing one. We saw it was called BR0, so let's use that. And yes, it is connected to MAAS. And as you might remember from earlier, the network for IPv4 is MAAS IPv4. That's what it's called in MAAS, and network for IPv6 is MAAS IPv6. Updating images seems fine. We can now have LXD dump a YAML version of all the questions we just answered. That's very useful if you want to then replicate that system, because you can just feed that YAML directly to LXD in it and not answer the questions interactively. So we can have it dump it, and then it's going to apply the config immediately. So we can see the configuration right there. And it's actually creating the cluster for us right now. There we go. So that's the first node in cluster. We've got a new set of LXD cluster commands. You can see here. But let's just do list the nodes. We see when you have a single one. And we can get more information on that node. We say it's a database node and what URL it's connected to. Now let's go to the second one and also run LXD in it. Yes, we want to do clustering. That node is fine. That's init its IP. And yes, we're joining an existing cluster. In this case, let's just join by IP for this time. Let's see what IP was that. That was 16.169. Just copy paste this in there. Just the fingerprint of the server. It's fine. What's the password? So that's cluster as we configured it earlier. It tells me that this system is going to be entirely wiped, as in all LXD data on the joining node will be completely wiped clean. That doesn't really matter since there is no data at this point. That's a completely fresh system, so that's fine. And it asks me what's the right storage backend to use, or what's the right storage device to use for that storage pool we created earlier. The first one, I used loop. I'm going to use loop on this system as well. So just hit enter. And we can once again have it print YAML if we want. That includes all the data needed to join as a cluster node. All right. So now we've got an actual cluster. We've got two nodes that are joined together. Now I'm running from the second node, and I can see that the first one is there. I can list containers. I can look at storage configuration. It's all there. So let's join the last one. Exact same workflow. Like to use clustering? Yes, I would. IP and everything is fine. We're joining existing cluster. That's the IP. Yes, the certificate looks fine. To the password, yeah, I'm fine with wiping everything. Use a loop, and let's not bother with the YAML this time. All right. So now I'm on the third node, and I can see everything. So let's launch a Ubuntu 16.04 container. Let's call it C1. So that's talking to the exact same LXD API as someone's used to from before clustering was a thing. Oh, that's an interesting one. Node with this host name already exists. So that's the MAAS integration being a bit wonky on this one. Let's try it again. Okay. Just checking that there's no conflicting container. There isn't. And MAAS is configured. Okay. Let's just. Oh, I know what's going on. What's happening, and I can show you that. The error is actually perfectly right. I just forgot about that. I actually have a second cluster set up on MAAS. Let me just share the MAAS screen again, because that actually makes sense. So if we go back to MAAS, we see also have a whole bunch of VMs down there. Those VMs also run a LXD cluster, a much larger one with 6 nodes that we're using for development right now. And I believe that on VM01, we actually have a container called C1. Yeah, there we go. So that's the problem, because since MAAS manages DNS for the entire network, it can't create a conflicting DNS record for that container, and that's what it's complaining about. So if we go back to the terminal, I should actually be able to, yeah, there we go. If I do host C1 MAAS Montreal, yeah, so we do have a container called C1 already. It should even be reachable and everything. Yeah, and that's running on a different LXD cluster. So that explains it. Let's just call it something else then. Let's go with D1. That shouldn't exist. It's probably not a good idea to have more than one LXD cluster running on the same MAAS subnet, just because this kind of stuff can happen. I forgot about that particular issue. All right, so now we've got a new container. It's called D1, and it's running on the Janet node. So even though I run the command on my third node called Noturo, since I didn't tell LXD where to place it, it just placed it on whatever it thought was least busy at the time. So now if I was to create D2, it's going to pick probably the second node. So my guess is that that will end up on Edfo. I'll just confirm that in a second. Container creation takes a little while the first time on any given node, because the image must be transferred internally within the cluster and then unpacked as in this case, a ZFS dataset. And then the container is created from that. So that can take a few seconds. There we go. Cool. So we've got 2 containers indeed on Edfo. Now, obviously, if I was to create D3, that would end up on Noturo, because that's the least busy node at this time. But I can tell LXD not to do that. And actually, I want D3 to be placed on Janet. That should be quite a bit faster, because this time it doesn't actually need to transfer the image. There we go. OK, so now I've got D3, which is created on that first node. And because I've got the MAAS integration done, they all have DNS records and can be pinged perfectly fine. There we go. We can also, I'm really hoping I'm not going to end up with an IP conflict somehow. So MAAS will tell me if I did. So let's try to override D2. Its NIC, and let's ask MAAS to give it, I don't know, 20? See if that works. LXC config device override D2. That's an interesting error. Just going with the slightly longer syntax in this case. All right. So now if we compare D1's config, there we go, expanded. So D1 we can see is configured, well, actually, it's configured on to use MAAS. D2 is not configured with its static IP. What else can we show of the cluster? So this cluster only has 3 nodes, which means that they're all database nodes. This will actually vary. If you had more nodes than that, only 3 of them will be database nodes. By default, the first 3, if some of them go down, then that can change. Everything else pretty much behaves exactly as it would if it wasn't a cluster. So say listing containers works that way. Listing images, no big surprise when you use the single image. I could create another container to D4 from an Alpine image. All right. That ended up on Natura because it didn't actually have any container yet. There you go. It's got an IP and everything. Storage pools, we only have one. If I look inside it, we see it's used on this node by container D4. We can, so if we list the volumes of that local storage pool, there we go. We see we've got 4 containers, 2 copy of the Ubuntu image, 1 copy of the Alpine image, and we can see what node they're on. And now switching just back to MAAS. All right. So the MAAS integration piece makes it so that MAAS itself does the IP allocation and configures the HTTP instead of having LXD run all of that itself. And that also means that all containers that are running are now listed directly in MAAS with their IPv6 and IPv6 and IPv4 addresses, their MAC address. Deleting the container will delete it from there, adding one will just add it. We can see some busier nodes with that other cluster I've got running. So if we go there, containers, you can see that machine is running a whole bunch of containers, including one that's using Ceph storage that we call on Ceph. And maybe lastly, just how to connect to a LXD cluster remotely, because that can be interesting too. So just showing that terminal again. There we go. So if I now get a terminal on my own laptop, I can add LXD remote, let's call that remote cluster, and let's pass it any of the nodes. So there I go. Yeah, password. And now I can list cluster, and that's going to get me my cluster view. I could also, especially if I'm not going to be running containers locally, but only against a cluster, I can just set the cluster as my default remote, at which point I'm just always interacting with the cluster rather than my local nodes. And to reset that, I can just set it back to local, which then shows my local containers instead. There we go. One thing that's might be interesting is the cluster's TLS certificate is shared between all nodes. So you can totally create a DNS record that round robins between all of your cluster nodes, and client can just add that. Then if one of your nodes will go down, you can just remove it from DNS round robin, and your clients will still work fine, albeit not being able to see whatever's running on that one node. We can see how that behaves. So say if I was to shut down, let's shut down the first node. If I was to shut down Janet, that machine can go down. And I look at the cluster state. Right now, it's internally stuck, effectively because of the database is trying to figure out what's going on. So we'll see right now it still thinks everything is fully operational. I believe there's a 30 seconds timeout for database operations to notice a node as being completely offline and then mark it as not available. And we can see that to some extent already here. We see the two containers that are running on that first node, Janet, are now both marked as error state. So we can't query whether they're running or not. We don't know what they're doing. And now if we look at the cluster list, we can see no heartbeat for the past 48 seconds. And that should increase. Once the node comes back online, it's going to catch up on whatever it missed and then be back to working order. We can confirm that. Let's create D5. There's no problem creating new containers or doing anything. You just can't place anything on that first node. So obviously it won't have picked the first node because it's offline. So it just picked headful instead for that particular container. There we go. So it's working perfectly fine. When that system comes back online, it will sync its database and then show back up on there. Everything fine. And that's it for LXD clustering. As you can see, you can just install that very easily for yourself through the LXD snap. It's pretty simple to configure and use. If you've got a bunch of machines laying around that are connected to the same network, you can make that happen very easily. I would definitely encourage you to test it and give us feedback on how that's working for you. Thank you.